You are listening to Demystifying Organizations. In partnership with McGraw-Hill Education, I'm your host, Jeff Shatton. My guest today is Tom Davenport, who is a professor of information technology and management at Babson College, the co-founder of the International Institute for Analytics, a fellow of the MIT Initiative for the Digital Economy, and a senior advisor to Deloitte Analytics. He has written or edited 20 books and over 250 print or digital articles for Harvard Business Review, Sloan Management Review, the Financial Times, and many other publications. He earned his Ph.D. from Harvard and is taught at the Harvard Business School and the University of Chicago. I'd like to welcome to the podcast Tom Davenport. Tom, thanks so much for joining me.
My pleasure, Jeff. Happy to be here.
So you have extensive work and research and consulting on artificial intelligence. I've been working through the AI Advantage and some of your recent work online. So just for our audience, if we can just start, everyone hears the term artificial intelligence thrown around all the time. So just fundamentally, what separates artificial intelligence from just typical computing, typical things that you encounter on the internet?
Well, there's a lot of debate about that. And in all of the areas that I've researched over the years in knowledge management and analytics and so on, I've not really been a definitional purist, but the general consensus, I think, about AI is that it's technology that performs tasks that were previously only possible by human brains, things like judgment and perception and decision making. It's not a perfect definition because there's some things that AI does that humans could have never done, like making decisions on the basis of vast amounts of data. And two, it's not clear exactly which technologies fall into that category. There's an old complaint that as soon as we have mastered something like, optical character recognition, then it sort of drops out of what's considered AI. So it's a tough area to define, but in general, it's stuff that used to require human brains and doesn't anymore.
And so where would most people encounter AI if they hear the word, but they're like, I don't necessarily see that all that much?
Well, they'd be wrong because it's pretty much everywhere in our society. I mean, perhaps the most visible place is these natural language processing based smart speakers that a lot of people have. Amazon Echo / do I want to? No, I guess I don't have one around. Alexa.
We have one.
Often get into trouble with that. And Google Home and Apple Siri and so on. But far earlier than that, there were machine learning applications that were very widely used. Perhaps the best known is the idea of credit scoring, which has been going on since the late 1960s or so, where we use a model to predict whether you are likely to pay back your bills or not without actually having data on you.
So I want to jump into that because this is where we kind of see the big step. So basic regression, for those who are not statistically inclined, you're basically taking a bunch of different plot points and then trying to run a line through it that's going to pull those together. So, for example, if we wanted to know the relationship between weight and height, we could map those out on an X and Y axis between weight and height, and we could try and see, is there a strong correlation and is there a line running through it? It's actually going to be a very strong line. And so we've used regression and statistics for a very long time to try and make sense of data that can be all over the board. Correct me if I'm wrong, but your FICO score was probably originally simply just using regression.
Yeah, in fact, I think it still does. Perhaps some relatively sophisticated forms of regression. But if you are, to use your example, if you're trying to predict weight from height, and you have created a model based on people for which you know both weight and height, and then you use that model for people for whom you know height but not weight, and you're predicting weight. That's supervised machine learning. It's a simple form of it, but it's why I often say there is basically no distinction between predictive analytics and the more straightforward forms of machine learning.
Right. And so if that's like the early crude version, right, which is just going to predict one variable versus another, the stuff that people interact with today is incredibly complex, which would be, right, when I Google something, when I Google President Trump, it's going to give different results than if somebody else Googles President Trump, because it knows their history and is going to throw in entirely different results for them than it will for me. We could think of Alexa. We could think of Netflix's algorithm that puts out, what movies my wife and I are going to like, which are going to be very different than the movies that you're going to like.
Yeah, but all of that is basically personalized on the basis of data. It's different data, and not the description that you gave of regression, where you're fitting lines to data. Even the most sophisticated forms of machine learning, which I think are probably deep learning based neural networks, still fit lines to data. They fit a lot of lines to a lot more data, but it's still the same basic idea.
All right, then what's the next stage? So if we've kind of gone from predicting weight and height or FICO scores to personalized responses, where do we go next with this?
Well, we start looking,
or even where are we?
We start looking at forms of data that are a little different from rows and columns of numbers, which at least in their initial state. So a lot of the progress in recent times in AI has been in the area of image recognition and voice recognition, speech recognition, et cetera. And those still use, the basic statistical technique of fitting lines to data, but they use a very complex form of it with lots and lots of relatively abstract variables or features, as people often call it in machine learning, and a relatively uninterpretable model as an output. So it's not so good when you need an explanation of why you're identifying say a cat on the internet, but it's fine if an explanation doesn't really matter.
Right. So one of the confounding things, right, is that Deep Blue beat the world's greatest chess player in the mid-90s.
Yes.
And then it took until the early 2010s before algorithms could spot cats on the internet, which my 2-year-old son can do. So my 2-year-old son can identify a cat probably as good, if not better, than some of these algorithms. So what's the discrepancy between those two things?
Well, as I say, most of the statistical techniques in the past were largely for very, traditionally structured forms of data. And Deep Blue was, basically what happens in data science is you convert things to rows and columns of numbers. And Deep Blue was a sort of a brute force exercise in predicting the statistical likelihood of different chess moves, and it could evaluate a lot of different chess moves.
Right, because there's only a finite number of spaces on a chessboard and a finite number. It's huge. Yeah. I don't mean the number of spaces. There's a huge possibility of the number of chess moves that you can do, but it still could be fit into rows and columns.
Yeah, exactly. And basically the same technique is being used in some of the more recent game-related AI advances. It's just the models are a bit more sophisticated. They're able to learn from games they play against themselves, which I guess is a pretty big advance, but still, statistically based underlying it. And, the problem with statistical analysis is you typically need a lot of data. one of the things that your son can do, and that most humans can do pretty well, is we can make inferences from a very small amount of data, and they tend to be, quite accurate. And machines are not able to do that yet.
So what did it take for the machines to learn what a cat is?
Basically, if you mostly what it took is a lot of data on the ImageNet database. There are, at one point, I started counting the number of cats in ImageNet. It turned out to be a fool's errand. There,
Sure.
Thousands and thousands.
It was like what the internet was originally created
Yes,
for.
that's right. The greatest achievement of humankind on the internet.
Yeah.
The ImageNet is an open source database with lots and lots, millions, I think in roughly 15 million range of labeled images. And if you take a lot of labeled images and you say, okay, I know that's a cat, then you can start to identify the features or variables that best identify a cat. And if you were to look at the model, it wouldn't look like, two ears and a cute little nose and a fuzzy face. It would be a series of unidentifiable variables based on pixel brightness in an image. And so it's a great achievement, but I was just reading a few articles this morning, pretty easily thrown off by minor manipulations in the image. And that's one of the problem areas for deep learning. And one of the things that I think will make it difficult until we make some further advances, it'll make it difficult for that to power, say, autonomous vehicles, which is the technology that a lot of companies were planning on using for image recognition in autonomous vehicles. Because if it's raining, the image is going to look different, and certainly in snow and so on.
So do you not buy Elon Musk's recent statement that in the next year they'll effectively have fully autonomous cars?
No, I don't. I do buy his cars. I've had on my second Tesla now, and they're great cars, but I think it would be quite dangerous to rely on them for fully autonomous driving now. And my guess is that the next version will be better, but not good enough to rely on it fully. And interestingly, nobody else in the industry, the automobile industry, is quite as bullish anymore on short-term, fully autonomous driving as Elon Musk is. I saw last week that the head of Ford said, it's going to take several years. People are saying, we're 80 or 90% there, but the remaining 10 or 20% is going to take as long as the initial 80 or 90% did. So that suggests 10 or 15 more years at least.
Well, and also the consequence of mislabeling a cat is pretty low. With driverless cars, the consequence of making mistakes gets really high very quickly.
That's right. And you would think that regulators would want to know that this wouldn't happen very often, bad decision making through autonomous AI, and two, that when it did happen, we could find out what went wrong. And right now, neither of those are the case.
So I think let's peel back the layer a little bit between the difference between regression and this cat problem and what machines are actually doing to learn about the world and why it's so challenging to go from regression or the chess deep blue onto the cats and into like the problems with driverless vehicles. So for one, if you think about the actual learning that takes place when you say to somebody, "What is a cat?" And I hate that this is an example that we're using, but it'll suffice. There's a lot of complexity, and it's not exactly clear what it is that defines exactly a cat versus a dog. If you ask somebody, they'd say, "Well, I just kind of know, right? There's whiskers, there's this, there's that." But to a computer, that can be really confounding.
Well, certainly to say what the factors are, it can't do at all. And, it all comes down, a cat is no more understood by a computer than any other image that it looks at. It's all a matter of which pixels are which brightness and which ones aren't.
And so one of the things that Google is doing, that pretty much everybody will have experienced this, when you click the checkbox to make sure that you're human or not human, they show you a series of 9 windows and say, which ones are the street signs, which ones are cars, which ones are shops, and that's Google learning. That's their machine learning from you what qualifies as a street sign and what does not.
How can their way of creating free labeled data at their customers' expense?
So how are they going to take that and then turn that into some knowledge that will then be able to be used by a computer?
Well, again, it's creating labeled data. It's like, as we were saying earlier, it's identifying the weights of a particular individual when you have the height. And so you'll be able to say that is a beach scene. And then once you have enough of them, and you probably need, thousands and thousands, it's fortunate that Google has a lot of customers, they'll be able to say, okay, we have a model that can accurately identify a scene at a beach, or, I don't know what the right level of sort of descriptive granularity will be about these things, but you do need lots and lots of labeled images or labeled outcomes. If we're trying to predict what radiology images are potentially cancerous, then we'd have to have a series of labeled images saying, yeah, these people actually got cancer, and that lesion or whatever actually did lead to cancer, and then you could use it to predict whether other ones that look like it would also lead to cancer.
Do you think AI will, at some point, cure cancer?
Well, yeah. I mean, at least provide effective treatment strategies, yes. But it's also clear that it was a really bad idea for IBM to go after that as early in the process as it was with AI. Turns out to be much harder to cure cancer than it is to beat Jeopardy. Who knew? But but yeah, there are a lot of different types of cancer, and it's always very difficult to teach new languages to any sort of AI system, and that was part of the problem. And it's complicated by the fact that there's a big genetic role in cancer, which we really don't fully understand. We can't really say what genes are associated with cancer to any substantial degree. So I think we will. It'll be through some combination of AI, precision medicine, which is really predictive analytics, which, as I said, is a form of same as machine learning, but it's going to take a lot longer than certainly IBM thought.
Yeah. So the more complex something is, the harder it's going to be, and the further, the more noise that there is in the data, the more difficult it is to run any regression line. One of the things that I follow pretty seriously is AI and investing. And there are some completely algorithmic investment groups. There's one ticker, AIEQ, which is the first completely autonomous AI-driven investment vehicle. And the algorithm looks at millions of data points and every news story as it's coming out, and then invests accordingly. And the S&P 500 has crushed this tool. I mean, this tool has pretty much failed at every single point to keep up with the S&P 500. And part of this is that no matter how smart, and this is just my take, but no matter how smart the algorithms get, there's so much noise in investing data, right? So if Donald Trump, they have to predict, will Donald Trump tweet something? Well, that's very hard to predict. Then he tweets something out. How will markets respond to that particular tweet? Well, it's really hard to know how they'll respond. Then how will international actors respond to that? Well, that's tough to predict. Well, then there will be central banks around the world that might respond. How are they going to respond? How is that going to impact corporate earnings? Well, that'd be really hard to predict out. And so very quickly, you get this mishmash of interlocking events that really do drive markets, and these algorithms that are trying to predict how that's going to impact stock performance, and it becomes a mess.
Right, and we don't have lots of data on how the markets have reacted to Donald Trump's pronouncements in the past, because he hasn't been president for very long, which in my view is a good thing. So, uh, without really great data, there's only so much you can do. You're right. I've been quite interested in this issue of AI-based investing for a while. And I remember years ago, almost 2 decades ago, I invested in a Fidelity mutual fund called Disciplined Equity that was supposedly going to use, analytics and AI to beat the S&P 500, and it rarely has done so. It's still around, but it didn't make any money for me.
And it's going to be very challenging because there's just so much noise, and an algorithm cannot fix a problem if there's noise in the data. If it's unlimited noise, maybe like this. Imagine trying to build a computer and an artificial intelligence system to predict coin flipping, and at the end of the day, it would simply be unable to predict coin flipping because it's all noise.
Yeah, totally random. You mean?
Yeah.
Yeah, and I think another problem, and this is, I guess, good for us humans, is computers and algorithms are not very good at noticing that, or at least understanding that the world has changed. They can identify that their model is no longer a good predictor, and more and more we're going to have that automatically within machine learning models to say, this one isn't working very well anymore, boss. But knowing that the world has changed, that the variables that used to be good predictors of, I don't know, whether you're going to pay back your mortgage or not, or whether the stock market is going to go up or down, that changes over time. And even if you do have a lot of data from the past, as it was in the financial crisis, it may no longer be a good predictor in the future.
Where do you think technology, AI sits in terms of the hype curve? Is there more hype now than is bearing fruit? Is there more that's going on in the background than the hype? Where does that sit?
I think it's cooling off a little bit. One hopes that it doesn't lead to another AI winter. I don't think it will. But there's still a fair amount of hype about it. And, I've been pushing the idea of boring AI, that the really sexy stuff may work at times. I sometimes refer to them as moonshots, but many times they don't. And they'll sort of set back the field and set back enthusiasm within an organization. But the boring stuff works amazingly well, both the boring methods, like machine learning has been around for a long time. It's pretty boring by now. Robotic process automation, which some might dispute as AI, but I generally put it in that category. Very boring, structured task performance, but hey, it works really well and gets great return on investment. That stuff is quite successful. It's the really ambitious stuff that's problematic, even for the Amazons of the world. They have had problems with their more aggressive projects.
Like what?
Well, they were slow on Go. Amazon Go stores, which identify what you bought without any sort of human person at the point of sale, had some problems.
Yeah, I saw the ads from that. There's 1 or 2 stores. Are they still around?
Yeah, they're now, I think, 11 or 12, but
okay.
They not in Lexington, Virginia yet, though. Huh? No, we don't have one in Boston yet either. New York has one, and San Francisco has 3 or 4. Seattle has a couple. Chicago, but anyway, they now they work pretty well, but they took a while. And Amazon also, Jeff Bezos anyway, predicted that you'd have delivery to your home by autonomous drone in 2018, and I don't know, none have arrived at my house yet. I don't know about yours, but
that might be an FAA issue.
Well, I think there are always going to be some regulatory challenges, but even he said the great bulk of what they do with machine learning is, I think his term was, quietly but meaningfully improving core operations. So it's kind of that boring stuff.
Right. You think of them of their warehouses and the use of moving packaged goods. I mean, you think of how much AI has changed logistics and supply chains. Is that the kind of areas you think of as boring AI?
Yeah, that's certainly one example. I think, slight improvements in their recommendation algorithms, et cetera. It's just, little by little, we get better at things, just as we did with data and analytics. And that's a big part of what AI is about. So it's not surprising.
Given all the knowledge that we have and have had about AI, why didn't Facebook detect Russian interference?
Well, I don't think they were looking for it. And that's one example of how things had changed. There were an awful lot of things that they weren't really looking for. And I think they also had placed perhaps too much faith in AI overall at detecting all sorts of problems, profane images of various types, people, trying to kill themselves on Facebook. YouTube had similar problems. So it turns out it's really hard to do those things. There are, I guess, almost infinite numbers of variations.
They have people actually detecting that. There was just a piece on the Washington Post podcast about the tens of thousands of people that are hired in the Philippines just to screen out disgusting images on Facebook and Twitter.
Yeah, well, that was because the AI didn't work. Believe me, they didn't want to hire those 10,000 or so people. It was a response to the fact that they did not succeed with AI doing it.
So, kind of going off that topic, where do you see the future in terms of jobs in AI and displacement of jobs?
Well, I've gone back and forth on it a lot. When I started working on this in 2014 or so, and I believed the hype about jobs being at risk, but then I started working on a book with a woman, Julia Kirby, who didn't agree with me, and she kind of persuaded me that augmentation was a more likely future than large-scale automation. We wrote the book about it. It was called "Only Humans Need Apply," and then.
And what would the augmented future look like?
Well, we tried to be somewhat systematic about it, and we identified 5 different, I guess, strategies that humans could take to augment the work of smart machines. 3 of them involved working closely with AI technologies, and 2 of them were sort of trying to do things that AI either couldn't do or was unlikely to do. So I generally still believe that. I believe that augmentation is a much better strategy, more suitable to innovation, I think, in your business processes. Obviously, it's more likely to get your people to cooperate with you in introducing the new technology. But more recently, I've been working with Deloitte on some surveys of executives who understand AI and what their companies are doing with it. And then the latest one in the 2018 survey in the US, 63% of managers said they wanted to automate as many jobs as possible to cut costs. And then we also asked, are you interested in retraining your existing workforce, or would you be just as happy to, get rid of them and hire new people? And only 10% said, we're really committed to training our existing workforce. So I don't know, that was very, very surprising.
Yeah, that's a true testament of management opinion.
Yeah, I don't know if you saw it, but there was also a New York Times article about some of the backroom discussions at the World Economic Forum in Davos in 2019. And the reporter suggested that while publicly, a lot of these executives said, "Oh yeah, we're committed to our retraining our workforce with AI and so on." Behind the scenes, they said, "Nah, we're going to get rid of them all, or many of
Wow.
them." So I think there's
Yeah.
kind of a conspiracy of silence going on among executives and maybe among AI vendors as well.
I mean, I'm not surprised. I just had the CEO of Progressive Insurance on the podcast last week. She was very clear that she was not for replacing workers. We'll take her at her word. But I think the broader issue is that executives are going to cut costs when they can in a competitive environment.
Yeah, well, that's a part of capitalism, I suppose. But
Yeah.
I like it better if they would at least, give it a shot to retrain their workers and try to get the maximum out of them. And there are some examples. Another company in the industry you mentioned, Allstate, did say that it was going to spend some money, not much. I think 8% of their big tax refund in 2018, they said they would spend to retrain workers. Although some.
I mean, Amazon's throwing it. It was something large.
Yeah.
It was like 700 million. Yeah. 700 million at retraining its employees. So I mean, that's a good sign. I mean, it's a true drop in the bucket.
Yeah, that's my other big example is Amazon. So it's good news, but I don't think there are very many companies that have made a commitment to retraining and even started retraining. I mean, I think the time to start doing it is now.
So one of the issues with retraining is that you are fundamentally trying to get employees to take on skills that are oftentimes way beyond what they can possibly take on. So I think this is the pessimistic argument, and I think what was made in the book, The Second Machine Age, by McAfee, that book was like maybe 5 years ago or so.
Yeah, they're both good friends of mine, Bryn Olson and McAfee. Yeah.
Right, but one of the retooling issues is that yes, some people are going to retool into these higher wage, higher skilled areas, but a lot of these jobs will become obsolete and will not be replaceable. And so you are forcing many people up the ladder, competing for ever fewer jobs.
Yeah, I mean, nobody knows that there are going to be ever fewer jobs. Some people say there are going to be a lot of new jobs created. Some people say that huge numbers are going to be automated. The fact is, nobody really knows.
Sure.
But I do agree that not everybody is going to want to be reskilled or is willing to, go to the effort to learn the skills that are necessary and may not even be capable.
Or can learn, right. Or they might want to, but are not capable.
Exactly. So I think that is true, but I think the time is now to start giving them a chance.
I was surprised in your book. Your book is from 2018, and I recognize some things change. But there was a study that you conducted that showed the overwhelming majority of companies are spending less than $10 million on cognitive technologies or on artificial intelligence. And I was surprised that the companies were spending such little money. Obviously, there's not Amazon and Google. These are, the broad sector of the economy. I was a little bit surprised by those findings. What do you make of those, and is that continuing?
Well, I think there's a big hierarchy. I sometimes explain it by looking at the number of projects. So there are a fair number of companies out there that have one or two projects in production. I mean, to go back to what you were saying about investing, you look at Vanguard, for example. They have a robo-advisor. It uses some rudimentary AI technology. It's kind of one big project.
I mean, hardly. All they're doing is just rebalancing automatically.
Well, and I'm familiar with the robo-advising. There's some scoring of individual investors about how likely they are to run out of money and so on. So as I say, it's not very sophisticated.
Yeah. It's really crude.
It's cheaper than I'm a customer of theirs. It's half the price of what they were doing before, which was no more sophisticated.
Yeah.
In any case, that's on my less sophisticated end. And you say, well, I don't know. I was doing a session on healthcare with a bunch of hospital CEOs last week, and Intermountain Healthcare has about maybe 50 or so projects. Pfizer has 150 or so AI projects. Then you get up to Capital One has about 1,000 or so.
Wow.
Google in 2016 they had 2,700 projects. Google/Alphabet. So you have this hierarchy. Some really aggressive, but most are closer to the vanguard, and they may not necessarily even have one large-scale project in production. They just have a lot of pilots and prototypes and proofs of concept.
So are those companies going to get left behind?
I think they are. I wrote a little piece with an AI guy at Genpact, the head of AI at Genpact, arguing that this was going to be an area where it's going to be tough to be a fast follower, that there's so much learning involved, so much time and effort to gather the data, hard to find the people who can do it well. So it's going to be really hard to adopt this late in the game and catch up.
Because it seems like the kind of thing you can't, as a Fortune 500 company, you can't go invest $2 million in AI. And I mean, it seems like it's too little, too late.
I agree. I mean, in this latest Deloitte survey, a lot of companies did say they were off and running, and they had a majority said they had executives identified to be, cheerleaders for this thing, and they had a strategy and a process for getting, prototypes into production. But I think, frankly, they were being a little overly optimistic. I don't see that in the companies that I work with.
So, from an investing standpoint, do you see that? So, there's two different theses, right? One would be that people should focus on, pick out tech firms and focus on technology funds, because that's going to continue to eat the world, or as Andreessen Horowitz says, software eats the world. And then the second thesis is that you'll come across is, well, the S&P 500, they'll all be adopting AI over time, and it'll effectively, the entire economy is just going to be eaten by AI, which will just include everybody.
Well, I've talked to some venture capitalists recently who say that every software company they talk to says they're an AI company. And since everybody uses software in this industry, is usage in this economy, I think it's fair to say that every company will be using some form of AI. But I think some will be a lot more aggressive than others. And if you're interested, if you believe in this, and I do over the long run, think it's going to transform organizations. Those that do it quite aggressively are, I think, far more likely to be successful.
Can you walk through how you see AI changing managerial decision making?
Well, it's an extension of what's happened with analytics and data. It tends to change first the decisions that are repeated often. So we have a lot of data that are typically tactical in nature. And I think mostly managers who make those kinds of decisions tend to be middle managers, not very senior managers. But the decisions that involve A, a lot of uncertainty, B, not much repetition. We haven't done this exact thing before under these circumstances. That's still going to be something that's done by humans, maybe with the aid of some data if you can get it. But in general, I think, it's really hard to get data on that type of decision, and no data pretty much means no AI. So we may well see, kind of further, I think there's already been some demise of middle management in the age of analytics. We'll see even more, I think, in the age of AI. Interesting.
Just have one more question. Which one or two companies that people have not heard of, that are not the obvious ones, do you think are doing some of the most exciting stuff in the AI space?
You mean?
Not Amazon, or Facebook. What's that?
Vendor-oriented tech companies?
It's however you define it. Just some of the companies that you think should be on people's radar that are just really interesting for their use of AI. That not the Amazons and Facebooks.
Well, I'll tell you some, and I am an advisor, I think, to all of these companies that I think are quite interesting. Data Robot is a company based in the Boston area that does automated machine learning, and I think automated machine learning is a fascinating technology because it opens up that form of AI to people who don't necessarily have strong quantitative backgrounds. It means you don't have to be a data scientist to succeed with AI. So I think that's going to be quite influential. And you are seeing a lot of other, big companies, Google, Microsoft, starting to adopt it. But DataRobot was earlier, and they're quite aggressive themselves. In this category of boring AI, I work with a company called Tamer that does AI to integrate data. One of the great problems of data-based decision making is it's too hard to integrate the data across different databases. I work with another company just sold, actually, called Recorded Future, that uses AI to analyze cybersecurity threat intelligence. So lots and lots of little niches, I think, that you can use AI for quite successfully.
All right. Well, we're about out of time. And I just want to thank you. This has been a fascinating conversation. I don't know how you keep up with all this. In any method what are your main news sources?
Well, I teach it, and that always helps, not to reveal any professional secrets, but that always helps to keep up with an area. And tons now of newsletters. I think I get probably 5 or 6 newsletters a day on AI. So the question is, can I find the time to read them all?
Right. All right. Well, thanks so much for this fascinating conversation.
My pleasure. Thanks for your question.
Thanks for listening to the podcast today. If you have any questions or comments, you can email me at jeffshatten1@gmail.com. You can tweet me at jeffshatten. If you like this podcast, press the subscribe button and make sure to rate it on iTunes so that other people can find it.